Today I'm going to talk about the TerraClimate dataset and do a little demonstration of how you can use it. So the TerraClimate dataset is an image collection that includes monthly data related to climate. We can see that the dataset availability is from 1958 to the present, and again, it's provided every month. It's also global coverage, and then we can click on the bands tab and see its resolution. And we can also see some of the variables that it presents to us. So we have EAT, or actual evapotranspiration. We have DEF, the climate water deficit, PDSI, which is the Palmer Drought Severity Index. We also have SWE, or SWE, which is snow water equivalent. This variable is really good if you want to understand snowpack in an area. And then there's also some variables on minimum temperature, maximum temperature, vapor pressure deficit. Let's import the data set. I'm going to name this variable TC, and then we can start exploring it. The first thing that we may want to do is start to filter down this image collection to represent only the data that we are interested in. I'm going to explore some of these climate variables just in the mountainous Colorado region. And then I also want to look at some variables in between the winter months and the spring months. So I'm going to start off by just creating a variable called TC winter. And I'll take that TerraClimate image collection and filter it by the calendar range to just get winter months. So in order to do that, I'm going to use this function called EEFilter calendar range. And then I'm going to add in here the months that I'm interested in. So I'm going to put February and March, and then I have to indicate that these are months. And then I'll also filter it by the years 1984 to 2025, just because most of the satellite imagery that we work with is from 1984 on. Filter date. And then we could also do this for the spring as well. So I'll copy paste this and then edit it to represent the spring. So instead of February and March, I'll put May and June. And then we can add these to the map. So I'll first add my winter image. And remember that this is still an image collection. We have filtered it by these criteria, but in order to get just one image from this, we should summarize that image collection in some way. I'm going to use median, and then I'll clip it to my geometry. I also here want to indicate which climate band I'm interested in. I'm going to go ahead and select SWE. So that'll show us the snow water equivalent in this area. I'll add a quick palette. I'll just use brown, white, and blue. We'll figure out the min and the max once we visualize this, and then I'll name this SWE winter. So let's just visualize this and see what it looks like. And it looks completely white right now because our min and max haven't been figured out. So the min and the max, let's put min 0, max 320. And then I'm going to go ahead and create another map layer using my spring data set. So again, let's make sure that all of this is correct. Now that we've copy pasted this code, I'll change the layer name to SWE spring, and let's run that and see what it looks like. So the way that I've set up my palette is that areas with really low SWE, or snow water equivalent, are brown, and areas with high SWE are blue. So in our winter image, we do have a lot of areas that are blue, because again, it's winter, there's a lot of snow falling. But in the spring, the image is almost completely brown, which means that a lot of that snow has probably melted and run off. Let's also, while we're here, visualize another variable. So I'm going to copy paste this code. I'll add a comment here saying visualizing SWE. And then down here, let's visualize temperature. So a lot of this code can remain the same. There are some important things that we're going to change. So instead of SWE here, we're going to change it to a temperature band. So let me click in here and remind myself what the temperature band name is. So maximum temperature is TMMX. So I'll use that here. TMMX and put it on both. I'll also change the layer names here, TMMX. And then for this palette, the low values are going to represent low temperature and the high values are going to represent high temperature. So I'm going to use this blue, white, red palette. Awesome. Let's run this and then we might edit the min and max based off of what we find here. So I'm going to use -30 to 290. Let's run that and see what it looks like. Great. So you can tell that the temperature in the spring was clearly much higher than the temperature in the winter, which again matches what we might expect for winter versus spring temperatures. The last thing that I want to show you is how to make a chart showing these climate variables over time. So in order to make a chart using an image collection, I'm going to use a chart function called UI chart image series. We can click on this and it says this function generates a chart from an image collection, plots derived values of each band in a region across images. The arguments that we need here are the image collection, the region, the reducer, so how we want to summarize the pixel values within our geometry, the scale, and then optionally the X property as well. So I'll create a variable called chart winter SWE, and then I will put in this UI chart image series function. And within here, I'm going to add all of those arguments that I asked for. The image collection, which is our TC winter. And I need to, again, select that SWE band so that we just create the chart for SWE. We need our region, which is called geometry. We need the reducer. I'm going to use EE reducer mean, and then we need the scale. And the scale of this, again, is 4,638.3 meters. So I'll copy paste that here. Now I can print this chart winter SWE and see what happens. Great, so now we have this chart showing how SWE, or snow water equivalent, varies in the winter for each year. Let's do the same thing really quick with temperature. So I'm going to copy paste this code and say this one is for the temperature in the winter. So I'll select TMMX, and then the rest of this looks good. And then I'll change my variable name here and let's see what it comes up with. Great. So here's our chart showing temperature in the winter between 1984 and the present. You can continue to explore this data set using the different band names that it has, different seasons, different geometries. But as you can see, this data set presents really exciting opportunities to understand climate around the world.